Now, all the games that we've done thus far are games where, we assume each players are kind of playing once. Maybe they play twice, something like that, right? We know there's a lot of games, or actually I should say interactions between businesses where, it's not known when the two companies will stop competing against each other, right? They could compete against each other for a really long time, right? Sears and Macy's have been competing against each other for probably close to 100 years, right? And so when you have these games where they're repeated over and over, played against two companies over and over for an extended period of time, we can treat these as infinitely repeated games. That is, you play them over and over. Now, this means there's going to be an added dynamic because now we might have something that could allow us to achieve non-Nash equilibrium outcomes of games, okay? So what is an infinitely repeated game? Well, it's a game that's played over and over forever. So that part's pretty easy to figure out, okay? Now, what makes analyzing infinitely repeated games a little different is that you have to think about, well, what's my value of getting some money now versus the value of getting some money because I know I'm going to interact with this person, 5 years down the road, right? My value of money now, my value of money 5 years down the road is very different, right? And this brings us to the idea of present value, right? So if I'm a company and I'm competing against another company, right, I have a certain value of profits and money I can make today, but I probably value money and profits in the future a little differently, okay? So hopefully some of you have taken the managerial finance class and you know all about present value calculations. But the idea is you basically have to discount by the interest rate, okay? Because suppose I have the opportunity to have $1,000 now or some amount of money in the future. And so what would I be willing to take, right? Or what would I be willing to pay is maybe the way to think about it, right? Suppose I was going to get $1,000 2 years from now. So what discount would I take to have that $1,000 now? Would I take maybe $990 of it? Like willing to pay someone $10 so I could have that money now? Right? I mean, this is basically what we do when we borrow money, right? We need to have money now. We're willing to pay a premium to get that money. And so that's kind of the idea with present value calculations. We're basically discounting future money by the interest rate, okay? So if you recall, here's how you do present value calculations, right? Now for us, we're going to think about it in terms of a firm and profits, okay? So now, again, we're going to keep it very simple. We're going to suppose these two firms compete time after time, okay? And to keep it simple and to make the math simple, we're going to assume, each time they compete, the profits are about the same each time. That is, my profits I'm making every quarter are generally about the same. Now, in the real world, these fluctuate, but just to make the implications, the way we work through these problems easier, it's helpful just to assume the profit is the same each period, okay? So, this first equation here says, okay, look, the way we do this present value calculation is we say, okay, I value profit now, money I get now, as that particular value. But profits I'm going to get maybe in the future, maybe next quarter or next year, I discount by the interest rate, right? Because I'm willing to usually pay a price to get money now that I would have in the future, okay? And then 2 periods later, you have to discount it again, and again, you get discounted by the interest rate squared, okay? And on and on this repeats, okay? Now, mathematically, this is an infinite sum. It turns out you can use some nice mathematical properties, and this whole equation simplifies to this, the fact that the present value is 1 plus the interest rate divided by the interest rate times that profit that the firms get each period, okay? So this is the equation we can use to work through and solve these problems, okay? So let's take a look at this problem. All right, so let's just take a look at kind of this is what we call a Bertrand competition game. So two firms are competing or colluding potentially in Bertrand competition, right? Remember, Bertrand competition is one where both firms, if they're competing against each other, generally will set price equal to marginal cost. That is the low price, right? Which means they make zero profit, right? That's the implication of Bertrand competition, is that you end up making zero profit, okay? Now, if somehow they could get together and collude and act like a monopolist, right? They could each, right, reduce quantity, raise prices, and make 10 million each, okay? But as we talked about before, for a lot of these firms, there's going to be an incentive to cheat on any sort of collusive agreement. And that's what these diagonal boxes show us, right? Whoever cheats on the collusive agreement, right? So if firm 2 charges a high price and firm 1 charges a low price and steals the market from him, right? Firm 1 gets all the money, firm 2 has a bunch of losses, right? Because they lose their standing in the market. And again, the opposite's the case if firm 1 does the high price and then firm 2 ends up going in and stealing the market, okay? So the question is, what does our kind of basic analysis of game theory tell us about this game? And if this game is played over and over and over again, can we potentially get a different outcome, okay? And so first, let's just do the basic game theory analysis. Let's see if there is a Nash equilibrium and dominant strategies and so forth, okay? So again, pretend we are firm 1. With your hand, just cover up the column on the right, okay? And we know that if firm 1 knows that firm 2 is going to charge a low price, then if you're firm 1, you would also charge a low price and earn zero profit, because that's better than a loss of $40 million, okay? Now we can do the same thing. Cover up the column on the left and ask the same question. If you're firm 1 and you know firm 2 is charging a high price, then yeah, you charge a low price and you steal that market from them and you make a ton of money, okay? So it's clear firm 1, player 1, has a dominant strategy to price low, okay? Now if you do the same analysis for firm 2, sure enough, you're going to find that firm 2 also has a dominant strategy to price low, right? Both of these will be underlined, okay? So they both have dominant strategies, which means this is our Nash equilibrium, okay? So, Nash equilibrium is when both firms price low, okay? All right, well, the question we want to address now is there an instance, because this is an infinitely repeated game, is there ever an instance where both firms could collude and reach this, where they charge the monopoly price, okay? Now, it turns out it is the case, because what we have to do is figure out, okay, what is the present value of them competing and colluding over time? And if that present value is ever higher than them basically cheating and then going to Bertrand competition, then maybe we can sustain this monopoly collusive outcome, okay? So basically what we have to figure out is, okay, is the present value of colluding greater than the present value of competing, okay? Okay, and what I mean by this is that this is the value if a firm cheats once. Okay, so let's walk through this, okay? Okay, so what's the present value of colluding? Well, present value of colluding, we'll do PV and we'll call it COLL just to make it easier. Well, this is going to be 1 plus I over I, and again, this is for each firm, times the profit. So each firm would get 10 million if they colluded. So every period they'd get 10 million. So times 10. Okay? All right. Well, what's the present value of cheating on the agreement? Well, it means if you were to cheat, you'd get 50 million. But then after that, there's no more cooperation, right? Your competitor is not going to collude with you anymore. So you get 50 million one period, and then after that, it's back to the competitive outcome of zero profit, okay? So the present value of kind of cheating, we'll say, is equal to 50 million. You get 50 million by cheating once, and then after that, you get zero every time. Plus 0, plus on and on and on, right? Because you go back to basically competing, okay? So what we have to answer is, all right, when is it the case where the present value of colluding, which is 1 plus I over I times 10, when is that greater than the 50 million? Because you only get 50 million if you cheat once, and then you go back to competing, okay? All right, so I've got some space on the next slide, and let's kind of talk through that, okay? Now, what we're going to get to on the next slide once we work, well, second slide from now, once we work through this, is this idea of punishing, right? And that's kind of what we're talking about here, right? If you maintain this collusive agreement, and then one of the firm cheats once, after that, the other firm punishes, okay? We'll kind of talk about what that means, okay? So we have 1 plus I over I times 10 is greater than 50 million, okay? So 1 plus I over I times 10 greater than 50, okay? So let's divide by 10. This is 1 plus I over I is greater than 5. Now let's multiply by I, greater than 5i, okay? So I multiply both sides by I, got it over on this side. Again, I is going to end up being positive, so don't have to worry about flipping signs when we multiply by a negative, okay? So now let's bring the I over to the other side. That means 1 greater than 4i, which means if we flip it around, this means I is less than 1/4, okay? That is, collusion can be maintained if the interest rate is below 25%. Okay? So, what this means is that if firms are competing against each other over and over and over, there might be a way for them to maintain this collusive outcome, because it turns out over the long haul, over a long period of time, if they both kind of act like a monopolist, they end up making more money than if they try to screw the other firm over and try to compete against each other, okay? So working through this type of game, we realize that, oh, look, we have figured out the interest rate that can maintain collusion. That is, to sustain this outcome here of both of them setting a high price and making 10 million, that could be maintained if the interest rate is below 25%, okay? Now, another way to think about this is this. Like, why does it make sense that the interest rate would be below 25% to maintain this collusive outcome? Here's what it means, okay? If the interest rate was above 25%, now, interest rates are never above 25% unless you're talking about crazy junk bonds, okay? But let's suppose interest rate was 30%. The reason why collusion can't work then is because of this. What it means is that a firm could cheat on the other firm once, take that $50 million they get, and even though they never get another dime thereafter because they're in that low price war, that $50 million could then be invested at 30% interest rate, and they would end up making more money than if they cooperated. That's one way to think about it, right? Given a low enough interest rate, it makes more sense for a firm not to try to cheat and instead to try to collude, okay? That's what it means when you get this interest rate that's below, say, 25%, right? So a lower interest rate means that they would be able to collude because in the long run, it's better off for them to do this and to act like monopolists. Now, again, legally, this is illegal in the United States, but again, some firms try to do this, okay? Now, let's talk about a trigger strategy, okay? The trigger strategy we just used in this example we call a grim trigger strategy. I'll get to that in a second. But a trigger strategy is basically a strategy used in a game where you evaluate, or your play this round depends on what the player did last round, okay? So it's a strategy in the game that depends on the past play of the other player, right? So that is, I will cooperate with you in this game each time we play, but as soon as you screw me over, I'm going to punish you, right? And so that's kind of a trigger strategy. So that is, past play by one of the players affects what you do now, okay? So the strategy we just talked about is called the grim trigger strategy. That is, it's called the grim trigger strategy because it means there's no forgiveness. It's grim. And basically that is, I'll cooperate with you as long as you cooperate with me. But as soon as you cheat, as soon as you break this deal, I will never cooperate with you again. It's called the grim trigger strategy. And that's essentially what we did when we analyzed this game. We basically said, look, as soon as one firm cheats, they make that $50 million. But then after that, forever, you make zero, right? This is that 0 plus 0 plus 0 over and over again, okay? And so that we call a grim trigger strategy, all right? Now, typically, if we were in class, I would work through the general form of this type of game. But here are some equations to kind of at least help you as you kind of work through some of these problems, okay? Now, this is kind of a general form, and this is 3 different ways to kind of express the exact same equation, okay? And this is basically a general equation to solve these problems where you're looking at maintaining that kind of collusive or cooperative outcome, the non-Nash equilibrium outcome, okay? Okay, so let me explain what each of these terms means, right? Pi co-op, this is the cooperative profit, okay? Pi Nash, this is the profit that's gained from the Nash equilibrium, okay? Pi cheat, this is the money you get one time when you cheat on the collusive agreement. And again, we have pi cooperative again, okay? So let's just draw the game we had, and I'll kind of label each of these, okay? Okay, so we had 10, we had 0, and then when this was low, this was high price, okay, and this is player 1. This is player 2, okay? And let's see, this is again low, and let me switch to blue for this. This is low, high, this is player 2, okay. And so we have 0 here, and so if player 1 does low and player 2 goes high, then that's when player 2 loses all the money. Actually, let me just look up here and just write these down. So negative 40 million and 50 million. So negative 40 over here. And let's change this to 50. Okay. Which means we're going to have the opposite here. This is negative 40. And then player 2 gets 50. Okay. And 10 here. Okay. So pi Nash is this here. These outcomes here are pi Nash. That is, it's the profit each firm gets when they play the Nash equilibrium outcome. Okay. Now, the profit that is cooperative is this one. So the 10 million. This is pi cooperative. Okay, that is, this is the non-Nash equilibrium outcome that they're trying to achieve, that monopoly outcome that we don't really want them to achieve, but the firms might try to achieve, okay? And lastly, the pi that is cheating is the 50, right? It's the money a firm gets when they cheat on that other company. So this is pi cheat, okay? And again, it's down here as well. This is pi when they cheat. Okay, So you don't have to kind of work through the math we did every single time. You can actually just use these simple equations to derive the interest rate, okay? Now the book actually tends to have these two equations, book and book. I'm not sure why the book prefers these ones, because if you just rearrange it, you get this one, because a lot of times you're solving for the interest rate, and it just makes sense to have it in that form. But each of these are identical. Each of these are identical equations. Okay, so they're all just rearranged versions of each other. Okay, now let's kind of wrap up this video by talking about things that will affect firms' ability to collude. That is, to kind of get together, be dastardly people, and try to act like a monopolist together. Okay. Now, the number of firms. So if there are a few firms, then it is easier to collude. Right? Because you got 2 or 3 firms, they can get together and they can kind of collude on certain things. So for example, cell phone companies do this all the time. And this is something that most people are not aware of. But the way cell phone companies collude is they actually divide up areas and with spectrum and cell towers, right? So what they do is they give certain companies little local monopolies in certain areas. And then that way they can charge prices and they have a monopoly in a particular area. Now, the FCC, the Federal Communications Commission, which is in charge of assigning the bandwidth for all these types of communications, hates this and always tries to prevent it. But companies have very sophisticated ways of trying to achieve this, right? And so it's much easier to do this if you have fewer firms. So if you have many firms, then it is hard to achieve collusion. Okay, hard to collude. Okay. Now another issue is firm size, and that is firm size really relates to is a company big enough? Let's say is a company big enough or have enough money to monitor competitors, right? So if I'm a small struggling company, I don't have time or the money to try to monitor my competitors to see if they're adhering to any sort of collusive agreement, right? But if I'm a big firm with lots of money, then yeah, I can hire a staff. I can hire some lawyers. I can be like, hey, go sniff out what they're doing and figure out if they're breaking our, again, illegal collusive agreement. Okay. All right. Now there is overt collusion, and again, this is illegal in the United States, but this is basically where you collude and you make it known, right? So this is collusion that is known. Okay. So this is what OPEC does, right? OPEC is a known cartel. They're trying to control the world market for oil. Now, they can do it less successfully these days because there's a lot more firms, right, than there used to be long ago, okay? Now, tacit collusion is where you kind of collude in secret ways. This is where you collude in secret ways. Okay, and there's all kinds of funny different stories about ways firms try to collude in this way. Airlines will try to collude on different routes, right? Have you ever wondered why, how come when I try to get to this destination, right, I can only fly, American, all right? Where if I fly Delta, it routes me through, Timbuktu and then back around there, right? So there's ways that airlines can kind of divide up routes, but then when the Department of Justice gets after them, they can be like, I don't know what you're talking about. We just flew these routes. We didn't talk, right? So there's kind of secret ways that companies can try to collude, and we call it tacit collusion. That is, it's kind of secretive. You can kind of wink, wink, nod, nod, and kind of collude in these ways. It's really difficult to detect. Okay, so it is difficult to detect. Difficult for Department of Justice to detect. Okay. Now, the last piece we want to talk about here is, well, actually, before I get to that, is there's going to be a homework problem that's going to come up this Saturday. It's going to ask about garbage trucks and labeling on cans and so forth, and whether that helps with collusion or not. And the idea is, if you have brands or labeling on garbage cans, then that actually helps firms be able to collude, because then I can detect if someone is encroaching on my turf. So there's going to be a homework question that's going to ask, okay, suppose there's these two competing garbage companies. And the question is going to ask whether it's helpful for them to have labels on their cans or not have labels. Well, it's helpful for collusion if they have labels, because then it's very easy for me to know if my competitor is encroaching on my territory, right? That is, garbage companies might say, hey, look, you take that half of the city, we'll take this half of the city, we'll charge higher prices, and that's how we'll collude, right? But if I start to see my competitors' garbage cans encroaching on my territory, then I know they're cheating, right? And I can detect it, right? So labeling, branding, things that allow us to detect if someone else is cheating on the collusive agreement help to be able to maintain collusion, okay? And lastly, there has to be a way to punish, right? If you can't punish someone for breaking the collusive agreement, then they're just going to break it, right? You have to have a credible way, and maybe we'll say low cost way to punish other firms. Okay. Okay, so that's it on infinitely repeated games. Next up is finitely repeated games.